This is 1.2 part 2. Now we're going to talk about the distance between 2 points. So in general, the distance between 2 points is the length of the segment with those 2 points as endpoints. So what this means, if I have any 2 points in space, the distance between them is just going to be a segment connecting those 2 points. So it's basically the shortest path between those 2 points. And when we're talking about distance, it's important to note that distance is always positive. So if I think about traveling, which I think is the best example of distance, if I'm starting in Reno, so right here, and I want to go 100 miles east towards Utah, I would call this 100 miles. However, if I wanted to go in the exact opposite direction towards California and I wanted to travel 100 miles west, I would still call this 100 miles. And so when we talk about distance, this is going to be a number that's always positive because we're just talking about how many steps would it take to get from one to the other. We don't care whether that is a positive or a negative value on the number line. So if we're just looking at distance specifically on a number line, what we're going to do is, in order to maintain that that number is always positive, we're going to subtract our 2 points and then we're going to take the absolute value. So over here on the left, I have this line PQ, and then I have a segment created by these 2 endpoints. So this little segment in between here, this is going to be my segment PQ. And over here it says the length of segment PQ is equal to the absolute value of x2 minus x1, or x1 minus x2. And this x1 and x2 are just coordinate points that I used to label my p and my q. So I'm calling my p x1 and I'm calling my q x2. And so I could subtract x2 from x1 or x1 from x2, and it won't matter. As long as I'm taking the absolute value, I'll always get the same. So if I'm looking at my number line here, it says example, find BE. So the distance is really the space between these points. So I could, if I wanted to, just count how many spaces there are between B and E, which is 1, 2, 3, 4, 5, 6, 7, 8 spaces. However, if I wanted to be more formal about it, I would plug them into my equation. So I would take the absolute value of, and I can go either direction. I could do -6 minus 2, or I could do 2 minus -6. Absolute value. And this becomes absolute value of -8, which is just 8. And this is just plus absolute value of 8, which is 8. So whether I'm counting the spaces or I'm taking the absolute value and subtracting those 2 points, I'm always going to get 8. So it's pretty simple on a number line, and like I said, we could just count the spaces because it's very physically easy to see. However, that might not be as easy if we're talking about numbers with decimals, but when we're talking about whole numbers, it's pretty easy to see the spaces. However, the formula is going to get a little bit more complicated once we move to the coordinate plane, because we're going to have something like a space over here, or a point over here, and then a point over here in space, where the line between these 2 points, the distance between those 2 points, the measure of that segment isn't going to be super obvious, and we can't just count from one space to the next because our spaces move vertically and horizontally. So our formula for finding distance in the coordinate plane is going to be PQ is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So if you look over here on my left, I have my little coordinate plane. I have my x-axis, my y-axis, and my little origin at their intersection, which is 0. And I have my point P and I have my point Q in space, but now they're just sort of hanging out in random places, and I can't really tell how many spaces there are between them. I can't really count it visually. Oh no, I didn't mean to do that. Let's redraw that segment. So what I did is I relabeled my P as a point x comma y, and I just called this x1 and y1, and then I relabeled my Q as the point in the coordinate system x2 comma y2. And so I'm taking the square root, and then I'm taking my x coordinates and subtracting them, and then squaring them, and I'm taking my y coordinates and subtracting them, and then squaring them. Now you're probably looking at this, if you've never seen it before, and you're saying, but why? Why is that the equation? Why does that give me the distance? And so I'm going to show you that this actually derives from the Pythagorean theorem, and this actually comes from solving a triangle. So if I go down, this is the same graph as I have up here. I've got my 2 points on the coordinate system. I can't count the steps between this point and this point, but what I can do is I can count the steps between my y values. I could count those easily because that's just these points on the number line. And I could also pretty easily count my x values. So I'm just basically walking in that right angle to get to the 2 points and creating a triangle. And then we could call this my A, and we could call this my B, and we could call this my C. And we have that formula, that Pythagorean theorem that says a squared plus b squared is equal to c squared. But A is really, it's the change in my x value. It's this horizontal change. So this is just the equation from the number line. This is the absolute value of x2, or x1 minus x2. Right? x2 minus x1. Let's just look at the formula. Oh, it's x2 first. Okay, so x2 minus x1, and then in absolute value, and then just plugging that into our A, we're going to square it, because our Pythagorean theorem squares it. And then B, this is our change in our y, so it's on the y number line, or the y-axis. So these are this is the absolute value from my point y1 and my point y2. So this is y2 minus y1 squared is equal to c squared. However, it's important to note that whenever I square something, I'm always going to have a positive number. So this square sort of eliminates the need for an absolute value sign. So I could rewrite this. It's just x2 minus x1 squared plus y2 minus y1 squared is equal to c squared. And then if I wanted to solve for c, the very last thing I would do is I would have to take the square root of c, since c is squared. And this would become c, I guess the square root. And I'm not going to put plus or minus here because, again, we're speaking specifically about distance, and distance is always going to be positive. So this is just the positive square root of x2 minus x1 squared plus y2 minus y1 squared. And that's going to be equal to the square root of c squared, which is just c. So now I've got the c, or the distance, between these 2 points, so we could call this also PQ, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so this is a big funky formula, so let's plug in some numbers and see how it works out. Sometimes it's just nice to see a good example. Alright, so I have an example down here. And it says, example, I have the point C is -4, -6, and I have D is 5, -1, and I should have said find the distance between the 2 points. Or I could just say find CD, which is the length of my segment CD. So I'm going to call this my x1, call this my y1, call this my x2, call this my y2. This is just my first x coordinate, my second x coordinate, and then my first y coordinate, my second y coordinate. And then we're going to plug it into our formula. So we have, let's rewrite the formula again. I've got CD, which is the length of my segment is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So what I'm going to do is I'm just going to plug in my values. So I'm going to say CD is equal to the square root of x2 is 5, and we've got minus negative 4 squared plus negative 1 minus negative 6 squared. Alright. And then these are going to become plus positives because we have minus negatives. And I get CD is equal to 5 plus 4 is 9 squared. And then I have negative 1 minus 6 is 5, so this equals 5 squared. And then finally, this is going to be CD is equal to, this is 81 plus 25, it's going to be equal to the square root of 106. And I could probably reduce that. Let's take a look. I don't know off the top of my head the factors of 106, so I'm just going to make a factor tree real fast. So this is going to be 2, and then 53, and I think 53 is our prime number. Yeah, it's not divisible by 3, and it's not divisible by 7, and it's not even, and it's definitely not divisible by 5, and it's not divisible. Yep. I think this is just going to be the square root of 106. Okay, so now what I want to do is I want to sort of go back and I want to check this like I would with the Pythagorean theorem. So I'm going to go back to this line and then I'm going to make a triangle out of it, and then I'm going to do it that way. Where's that point CD? Is this the same thing? Oh, yeah, sure enough, I graphed them already. I didn't even realize I graphed them. Okay, so I have my point. C is negative 4, negative 6, so it looks like I already plotted that at negative 4, negative 6, and then D is at 5, negative 1. So I went over 5 and then down negative 1. So what I'm going to do is I'm going to draw a triangle. So my goal is to find CD, so that's going to be my hypotenuse. So I'm going to count the steps from my C to my D in terms of my X, and then from my C to my D in terms of my Y. So this is going to be my A, and my B, and my C. And so the steps to go from this C to this D, I went over 1, 2, 3, 4, 5, 6, 7, 8, 9. So A is equal to 9. And then B, I went up 1, 2, 3, 4, 5. So this is 5. And then I could just say, 5 squared, or 9 squared, I guess. 9 squared plus 5 squared is equal to C squared. So 81 plus 25 is equal to C squared. So 106 is equal to C squared. So C, which is really CD, is equal to 106. The square root. So we could really do this both ways, and so you can see I sort of rewrote this distance formula, and instead of having my x2 minus my x1 squared, I just noted that this is really the change in my x, and this is the change in my y. So I could have, instead of doing what I did up here where I did 5 minus negative 4, I could have realized that there's 9 spaces in between those 2 points, and then the square root of 9 squared plus the square root of the change in my y. So my distance moving from this y to this one is 5 plus 5 squared, and I would have gotten the square root of 106.